Hello, my name is Wenqian Xu. I'm a beamline scientist from the Advanced Photon Source. First, I want to say to Bob, happy birthday. I'm very grateful to have been working with you at APS for the last 10 years or so, and very thankful to the GSAS-II software, which is really instrumental to my beamline work. So today I'm going to talk about retrieving X-ray polarization from 2D data, which is a small but very useful function built by Bob, added to GSAS-II a few years back. So I actually knew Bob before GSAS-II. The year I came to the graduate school, the first year, 2005, I started learning GSAS and Expert GUI. And that's how I know Bob and Brian's names. Throughout the years of my PhD and postdoc, GSAS is probably what I use most as the academic software. I use it almost like every week or every other week. But during that, like 8-9 years, I only got one time to meet Bob. So that's a very precious moment, and I kept a proof of that. Here is a photo. I bet Bob can't remember when and where this was. He has been in so many workshops and probably in hundreds of photos like this with workshop students. It's just one of those photos. This was in 2006 in a neutron scattering workshop at UC Berkeley. The workshop was organized by Dr. Rudy Wenk. I have another photo, more people from the workshop, and you may recognize more faces here. And in 2014, I started working at APS at beamline 17BM, and since then I met Bob more often and mainly discussing GSAS-II questions I had. So 17BM is a typical powder beamline working with area detector, a model X-ray beam coming in, detector on the other direction, taking data at a very fast rate. This kind of setup is very good for in situ operando measurement, used by many X-ray beamlines, diffraction beamlines nowadays. So the image integration part from the 2D data to get 1D powder pattern is a routine and also very critical function that has these beamlines. Since the very beginning of 17BM, we decided to use GSAS-II to handle this job. Throughout the years, Bob, Brian, I, and Andre is another beamline scientist at 17BM. We had many discussions on how to make GSAS-II's image processing more adapted to beamline operations. And Bob and Brian have been really accommodating, and they built quite a few powerful functions that's really beneficial to our users, such as automatic image integration and also the wavelength calibration. Here is another function of getting polarization factors. We see what we see here is a glass slide, amorphous scatterer, and we see this oval shape. This is because X-ray is polarized. X-ray from synchrotron is highly polarized. But typically, people don't care too much about the polarization factor. When they reduce the data, they use arbitrary values between like 0.5, 0.95, and 1 just to get their data. That is actually most of the time will be okay because the effect of the wrong polar factor is mainly on the very high 2 theta angles. If your data really can reach this part. And you see the tail have a different intensity. That's because up to the very high 2 theta angle, you will get a difference, a contrast between the intensity here and the intensity at the horizontal part. So for most of the powder analysis, it's probably not that important. But if you think about, here is a catch here, let me say. If you mask out some areas, as you have to mask sometimes, shadows from sample chambers, or you have some unwanted scattering features here, you mark them out. As your integration code crosses the mask boundary, your integration actually will normalize the data when reaching the mask, right? Because it has different azimuth coverage. And if you have wrong polar factor, it will result in a kink like this, a discontinuity here or here. This discontinuity is still very small if you look here, but it will be amplified, especially when you do PDF analysis. So it's important to get the polarization factor right. So this feature, what we call the artifact, is actually the idea behind this method. So the function itself is actually very easy to use. There is a button you click, you set up a range of the 2 theta range. It will automatically adjust the polar factor and check several ranges across this region, and then average out and getting you the right polar factor. So that's a function built by Bob. It's really useful for quick check of the polar factor. But here is one thing to mention: your data has to be amorphous scattering and getting to a very high 2 theta value, and also the attenuation throughout the different azimuth angles should be the same. That's why we use a glass slide put perpendicular to the beam. So, okay, that's the end of my talk. In the end, I want to thank I need to thank Brian and Jim for holding the party for Bob. And Bob, thank you. I give you my best wishes. And that's the end. Thank you all for your attention.